Viewers like you make this program possible. Support your local PBS station.
In the heart of historic London, a brand new type of building is taking shape. A unique set of challenges has given rise to a world first. A prefabricated skyscraper, assembled by a tiny crew in an impossibly small space. On a super-fast schedule where every hour is accounted for months into the future. Nothing like this has ever been attempted, but if they can pull it off, it could change the way we build forever. This is the inside story of the world's most cutting-edge and ambitious construction project. It is the Leadenhall Building, and it is a super skyscraper. London has been building high-rises for almost 1,000 years. It began in 1066 with the Tower of London, built to intimidate the locals. It rose 90 feet and became Britain's first multi-story stone structure. St. Paul's, at least the fourth cathedral to stand on this site, reached 365 feet, more than 3 centuries ago.
The city has always understood high-rise and always understood that high-rise was the way of showing your strength and your success by marking your skyline.
After the air raids of the Second World War and terrorist attacks in the 1980s and 90s, which caused more than $1 billion worth of damage, as well as through successive financial booms, which each produced their own monuments, London has seen a constant cycle of construction, demolition, and reconstruction.
The greatest constant in London's history has been change. As Chief Planner for the City of London, I'm responsible for 4,000 years of history. This is the point where people have been trading for 2,000 years. I expect it to be the point where they will be trading for another 2,000.
Now, a new kind of skyscraper is rising. The Leadenhall Building. Its distinctive triangular shape has already earned it a nickname: the cheese grater. The people behind it believe it will change the way we build. It's 2 a.m. on a Friday morning in May 2012. While the city sleeps, 2 gigantic trucks make their way through the streets of London. They're carrying pieces of steel, 90 feet long and weighing more than 40 tons each. They travel by night, otherwise they'd bring daytime traffic to a standstill.
We've got 2 long heavy columns that have come special transport movement order by the police. We're running late because the police didn't pick them up till, I think, 1:30, 1:45.
When in position, these supersized pieces of steel will become part of a unique structure. London's newest skyscraper, the Leadenhall Building. 736 feet tall, 52 stories. It will wrap a 20,000-ton steel frame in 75,000 square feet of glass. The Leadenhall Building won't break any height records, but what makes it unique is the revolutionary way it's being built. Prefabricated off-site and assembled in the tightest of spaces. It's a totally new way of building big. The construction site is right in the heart of cramped, historic London, and that's what gives the builders their greatest challenge. The area they have to work in is tiny, just 10 feet wider than the building's footprint. If these columns don't go up tonight, there's nowhere to store them.
It's a London job. You foot through the buildings like that, so you're building out your boots, as I call it. But yeah, you'd normally have perhaps a bit more room.
What this means is that the Leadenhall Building can't be built like other skyscrapers. In the last 30 years, most tall buildings have been constructed using a concrete core. It's a design that produces great stability, but it also demands a serious amount of space. That's space to mix on site or accommodate a fleet of concrete trucks, and space for a massive workforce. Since at Leadenhall, none of that is possible, the building's designers hit upon two groundbreaking ideas. The first requires getting rid of the concrete and replacing it with steel. The only concrete you'll find in the Leadenhall Building is in the floors. Instead of having a massive central core, they planned a steel exoskeleton that would sit outside the building. The second space-saving idea is that all the work on this steel frame will be done not in London, but 200 miles away in the north of England. Here, mighty columns and beams are folded and pressed to withstand enormous stress. Next, the steelwork is passed on to another factory, where it's sandblasted, primed, and fireproofed. Then, it's stockpiled until the exact moment it is required on site, when all that's left to do is to bolt it into place. It's not construction, it's some assembly required on a monumental scale. The engineers are so confident in their new way of building that they've agreed to what seems like an impossible deadline. Work started in October 2011, and they committed to getting it up and running, power on, before the end of 2013. Just 26 months. In skyscraper terms, that's a sprint. But one tiny delay and the whole production line is thrown out of sync. In the long term, delays have massive financial implications. The Leadenhall Building's first paying tenants already have a moving-in date. The project is a joint venture between two of the world's biggest investment companies. They intend to lease out floor space and want the building open, making money as soon as possible. For every day lost, someone will have to pay damages. But right now, there are more immediate problems.
These adjacent buildings start taking deliveries, and from 4 a.m, which is past that now, they will start coming in. It's cutting it fine, but we're committed now, so we've got to keep going.
The column is meant to be going up 5 stories. But without explanation, the crane's emergency brake has kicked in. Until the column is in position, nothing else can happen on site.
There's an issue with the crane. We're trying to find out what it is now with the hoist brake of the crane. It jumped a couple of times, so it's just playing a bit of a waiting game at the minute. Not 100% sure what the problem is, but we're not good to go until somebody has a look at the hoist brake of the crane.
The crane is brand new, and its onboard computer thinks the column is over its safe working limit. And that's not something that Paul or his crew can solve. Paul's got no choice but to call the manufacturers for assistance. And they're 800 miles away, in Italy. It's now 7 a.m., and the day shift workers are starting to arrive on site. After a reset of the computer, they can take another shot at getting the columns in place. Finally, they have success, but it comes almost 8 hours late. It's a delay they can't afford. With workers ready and waiting to floor and glaze the structure, the domino effects can be far-reaching and costly. If they miss deadlines, the penalties will run into hundreds of thousands of dollars a week. And there's only 11,000 more pieces to go. By September, the structure is approaching the halfway mark. Today, they're starting to add flooring to the 19th level of the building's 52 stories. On a different build, you'd expect to see hundreds of workers pouring and smoothing concrete floors, with convoys of concrete trucks coming and going. But not at Leadenhall.
It's concrete planks. It's the floors, basically. We've put thousands of these in. It's basically a big jigsaw puzzle. They just fill the gaps in. One shift of lads puts the steel in, the other lot of lads come along and put the concrete slabs in.
Like almost everything else on this project, the floors are made off-site and delivered ready to be dropped into place. This $150 million plant was developed especially for the Leadenhall project. It may be the closest that pouring concrete ever gets to being cool.
Basically, it's the future of the construction industry, and off-site manufacturing is the one thing where we can make that massive change. They know that their floor is already made, we've manufactured it, it's the correct quality, and they know that it will come and arrive on time to allow them to install it in their slot on site.
The system only works with total precision, the right mix into the right mold, with gaps for all the utilities that will come later. Because things will happen fast when it gets to the site. Crane driver Christian Holliday and just 6 workers can complete an area nearly the size of 4 tennis courts in a single day. Pouring concrete on site would take 3 times as long and twice the manpower. By 10 a.m., Christian has laid 18 30-foot square floor slabs, weighing 2.5 tons each. To stay on target, he must lay a further 34 by the end of his shift. That's 1 every 10 minutes. Overseeing the work is 28-year-old project engineer Carl Wilkinson. It's his responsibility to ensure work doesn't fall behind schedule.
We have no logistics space here, so we have to work on a just-in-time delivery basis.
Just in time means nearly too late. It would be impossible to coordinate the delivery and installation of hundreds of thousands of components using conventional 2D plans. So, instead, they've created a 3D model of the entire structure, accurate down to the last bolt.
We've spent a lot of time in the 3D environment making sure that when things come to site, we've got that assurity that it all fits together and that it all works, and make the actual process on site as efficient as possible. We refer to it as digital engineering. Digital engineering for me really is a future for construction.
Every delivery, every crane lift, every beam, bolt, and cable fix has already been given a time slot. They've run the complete simulation and built the Leadenhall Building in a virtual world 37 times. But they only get one chance to build it for real.
It's fundamental to me that the works that are planned, that plan is followed. And I come in and these beams weren't here, or the bolts were missing at one end and it was on temporary pins, I'd have been going back and having to cancel deliveries that are already parked outside and then having to reschedule the works, and then you lose a day. This steelwork was all erected last night. The concrete planks are here now, so within a 24-hour shift, we'll have erected 2 stories of steelwork and we'll have a full floor plate complete. So we have to make sure the planning is absolutely perfect, so that as one trade is finishing, the next one is having their materials delivered, so you don't have any downtime in the actual craneage. It's an absolute obsession to look at the way the cranes are actually working. I dream about the cranes when I'm not at work.
For Carl, this is a career-defining job. He's never worked on anything this complex or expensive. He lives with the knowledge that a week's delay might cost his employers hundreds of thousands of dollars. And when he sees any deviation from the plan, he jumps on it.
That crane right now shouldn't be doing that operation, so it means a heated phone call in about 5 seconds. Jerry, I'm just up here though. TC3 is on the K braces. I know, we don't have any delays on that crane, mate.
Working in a glass box an 1/8 of a mile in the air is not for everybody.
Yeah, I wouldn't like to be up that crane. If you climb up the crane, you get seasick. It's like that, it sways all over the place, horrible.
This crane was built especially for the Leadenhall project. Operating it requires a steady hand and a steady nerve.
No, the crane moves quite a lot. If it didn't, it'd probably just snap it off. It's just basically a big fishing rod. So if you don't make these too comfortable, otherwise you'd probably want to go to sleep.
Christian has hit his 72 slab target for the day. The Leadenhall Building is now floored up to level 20. But to finish the job on time and on budget, he must continue at this pace for the next 7 months.
It's in.
As the new year arrives, the steelwork has climbed up past its neighbors to the 40th floor. Locals can't mistake the distinctive form for anything else. They call it the cheese grater. But its unusual shape is not just the whim of some architect. Building in London means adhering to some of the toughest planning regulations in the world. The higher you want to go, the harder it is to get permission. With a skyscraper, one concern trumps all the others: protecting the view of London's most important landmark, St. Paul's Cathedral. Rising from the ashes of the Great Fire of 1666, St. Paul's is the beating heart of London. It was the venue for Lord Admiral Nelson's funeral and Charles and Diana's wedding. During the Blitz in World War II, Winston Churchill ordered fire brigades to save it before any other building, because to lose it would destroy Britain's morale. In the last 10 years, high-rise construction has encroached on St. Paul's. The historic monument risks being lost in a forest of skyscrapers.
It is like Mission Impossible trying to put a tall building with St. Paul's with all of these key corridors that protect it. There's nothing in that background that is actually confusing the clarity of its shape. You know, it's one last view. You know, let's just protect that. But we tried a number of buildings that worked within that. So we had some that stepped and followed its profile, and others that kind of were slightly bigger and squarer. And so we did explore a number of versions of that. The clients, they just like the directness of the incline.
But preserving the clear view of St. Paul's comes at a huge cost. The wedge shape means that as the Leadenhall Building goes up, each floor becomes smaller.
It's the raison d'etre for the lean, but that gave us then the other design solutions to solve.
And in an industry where the higher the floor, the more valuable it is, owners of a skyscraper want more floor space, not less.
We've approximately calculated that usable space was about 350,000 square feet. And they said, well, to be honest, the figure has to begin with a 6.
The solution the architects hit upon is the key feature that makes this building design unique. To maximize efficiency, everything that isn't rentable floor space will be housed in a separate structure. A conventional skyscraper puts all its services, elevators, restrooms, and all the mechanical and electrical systems at the center of the building, where it takes up rentable floor space. In the Leadenhall Building, it's all moved to the back and packed into an ultra-efficient external spine, the North Core. The North Core is made up of 139 modular building blocks called tables, which stack one on top of the other, 3 to a floor.
The North Core has the washrooms in it, has all the services in it, has the lifts. So the office space is completely open floor plate. So that's the server, and this is the served.
What's really smart about how the North Core is being built is that each table comes to the site fully loaded with pipework, electrics, plumbing, and floor plates. That means it can go up in record time.
So just all the time just taking pressure off the construction site and taking pressure off the logistics.
The table units are manufactured to precise specifications in Northern Ireland. To keep up with the relentless schedule, they need to be 100% certain each component will slot exactly into position once it arrives on site. The production line process is familiar, but here, no one has ever had to manufacture anything this big or this complex before.
We've had to change our techniques quite a lot, from cutting, drilling, fabrication, final assembly. For us, we've got to make sure it's absolutely perfect. Every weld is absolutely consistently the same.
Normally, a skyscraper's structural steelwork is hidden. But the designers are so proud of this innovation that they've ordered each table to be sprayed a vivid shade of yellow so everyone can see it. As soon as the paint's dry, it's rushed across the Irish Sea to central England to be fitted out.
If you just look and you see how tight it is between each surfaces, how they're so compact. You can obviously see electrical containment, hot water, cold water, cooling water, chilled, sprinkler systems, electrical systems.
Designing and manufacturing something this sophisticated is an enormous challenge. But if forced to build this structure by conventional means, in the cramped, congested streets of London, meeting their deadline would be impossible.
If you had done this in a traditional build, they would have to get all these materials, piece by piece, to the site.
24 hours after landing from Northern Ireland, the table has everything it needs to be plugged straight into the building. March 2013. The Leadenhall Building is at 551 feet, 2/3 of its final 736-foot height. It's just 1 year since the very first North Core table arrived on site. In that time, a team of 24 people has assembled this: 41 floors of prefabricated modules. There are just 18 tables left to fit. Christian Holliday, the day shift crane operator, begins his daily commute. He needs to be in position, ready to lift, the moment the delivery trucks pull in. Otherwise, a carefully choreographed plan starts to unravel.
Where do you want me?
Up you come.
Working at a height of 650 feet, it's now down to Christian to maneuver this 42-ton table into its final position with fraction of an inch precision. The problem is, he's working blind.
I can't see what's going on down there.
Directing Christian from level 41, 120 feet below, is his banksman, Jamie Parry.
You just rely on the banksman. Basically, they are your eyes when you're blind. So without them, you couldn't operate. Down below, you can't see what's happening down there.
Keep Jimmy back, mate. Keep Jimmy back. Keep coming, mate. Keep it coming.
He just talks to me constantly. If he stops talking to me now, I stop lifting.
It gets a bit hair-raising some days if it's wet. The steel can be a bit slippy. It's not for everybody, let's say. A lot of people. I'll go home, talk to my friends, and they'll say, "Not a chance." But I go up there, not a chance. It still unnerves you every now and again, but it's what we do. So just don't look down.
Working blind at such extreme heights leaves no room for error.
Every load, every lift, you've got to concentrate, otherwise you can hurt somebody quite easily. You know, it's a responsible job. If I make a wrong move, then somebody's going to get hurt.
Drop your head a touch as you come down there, mate.
Faced with the narrowest of time slots and the smallest of spaces in which to maneuver,
Tight fit.
Keep it coming.
Everyone is counting on this massive piece of steel.
Ease that down. Ease that down.
Slotting right into place.
It's in. Back down for another.
Securing the tables couldn't be simpler or faster.
The basic tool we use is our podger. We line the holes up with this, push it through, and then we'll pop a bolt in. So it keeps my finger end safe, that does.
No concrete pouring, no welding. All it takes is a handful of bolts and the 42-ton table is locked into position. And since each North Core level is comprised of just 3 tables, working at top speed, the team can install a full level in a single day.
Any more wagons?
2 more, buddy.
Well, get them in.
They push on into the night. They're committed to a delivery date and a schedule, which means that work must run 24/7. By early May, the steel frame and precast floors are complete up to level 50. Just 2 floors to go until they reach the top. 2 cladding teams follow behind, transforming the Leadenhall Building from steel to glass. Traditionally, glass installation requires a large workforce and space for them to load and operate cranes. But because the North Core is already filled with services, there's no room to work like this. Once again, the unique nature of this structure has forced the engineers to innovate.
Hi guys, how's it going? Okay? Yeah, good.
The man in charge of cladding the North Core is Phil Sedge. Today, he's starting work on level 21. Phil's secret weapon is a revolutionary new system called Cerberus. Cerberus is a self-raising platform with a monorail that can be quickly moved from floor to floor. Glass panels can then be delivered to the right level and slid around the building into position. It's a custom-made system designed just for the Leadenhall Building. Using Cerberus, Phil and a crew of just 30 can clad 2 floors in a week. On the sloping south side, using more traditional cladding methods, is Phil's younger brother, Andy.
From the age of 16, I've worked with him. He's dragged me along.
Without Cerberus to help them, Andy's team simply uses a hoist and manpower to maneuver their panels into place. The 2 brothers aren't just racing to meet a deadline. They're racing against each other.
We've both had and worked on many projects together. I think in all sibling rivalry, there'll always be a competitiveness now.
I think my side of it is a lot more difficult than mine. There's a lot more architectural elements, so I've got a lot more finishes to look at.
Got a much more challenging system. It's much more intricate system to install, so generally I think I've got the harder task.
The brothers have until August to finish adding 17 acres of glass to the Leadenhall Building. It remains to be seen who will reach the finish line first, Phil and Cerberus.
Yesterday we managed to get 11 units in, so that was a pretty good day.
Or Andy, sticking to the tried and tested method.
They average about 20 a day for these external units. In the next 10 weeks, I believe we'll have a majority of the last sections of the office done.
The race is on. But despite the best laid plans, Andy and Phil are both at the mercy of something that can't be scheduled: the British weather.
Wednesday, Thursday last week, we were probably hit with some of the highest winds we've had on this project since Christmas time. So we've lost a lot to bad weather and high winds.
Anything over 20 miles per hour could easily catch the glass and smash it into the structure. Each panel is manufactured in China. Any replacement means a 6-week wait.
We had a 22nd July target date to try and achieve, but we realised that's probably slipped a couple of weeks. And if you keep losing, it gets to a point where you can't creep back. The life here has been a lot of hours, very stressful.
Unless Phil can find a way to get back on track, not only will he lose out to his little brother, but he's in danger of incurring huge financial penalties. It's now June. The framework is nearing completion, and the team has reached a critical phase in the construction process. For the past 12 months, surveyor Justin Carmichael has been tracking what in any other building would be a disturbing pattern.
The top of the building is leaning over to the north. Every 5 to 6 weeks, we see about 2 millimeters of movement.
The North Core is an ingenious solution to the problem of space. But loading all the services onto one side has caused the whole building to move.
It's an asymmetric building, so there's more load on the north side of the building than there is on the south, which means that the building is going to settle differently. The foundations are going to settle differently on the north and the south.
So as the building gets taller, it gets heavier and leans further to the north. Normally, this level of movement would be a horrifying design flaw. But here, these growing pains are not only accounted for, they were planned. It's all part of another world first that the engineers have called active alignment.
We allow the building to move sideways, and we monitor very carefully how much it's moving sideways, and then we pull it back again, back to the south.
The theory is that the Leadenhall Building's steel frame can be tightened up during the construction process. This will make it stand up straight. The building's steel frame, weighing 20,000 tons, is adjustable.
So it's a very particular kind of approach. We're not aware of any other skyscrapers that have tried to do this.
So far, it's only been tried in the lab, on a computer model. Steel erector Carl Martin is about to put the theory to the test.
Because nobody had done it before, we had to sort of start from scratch. So they lumbered me and said, "This is a good job for you."
This extraordinary process is only possible because of the Leadenhall Building's unique structural frame. To join vertical columns to horizontal beams and diagonal braces, the engineers designed 23-ton star-shaped pieces of steel known as nodes. When the building was erected, each of these joints was filled with a number of steel spacers called shims. By opening the joint, Carl should be able to remove the necessary number of shims and correct the building. First, Carl fits giant green clamps either side of the nodes. He places powerful jacks in each corner.
Wind it down, lock it off.
And inserts hydraulic pumps into each jack. It's the same principle as jacking up a car, except this is a 52-story skyscraper.
If a pipe goes, then you've got the high-pressure hydraulic oil that's going to come out. I said, what happens if one of them breaks? Make a big mess.
The nuts on the megabolts are loosened. And then 500 psi of pressure is released into each jack. At first, nothing happens. The joint remains clamped shut. The pressure is increased. Still, nothing.
We'll go flat out this time, hopefully.
The pressure is cranked up again. Each jack is now exerting the equivalent of 220 tons of pressure. Finally, movement. The entire structure above this point is now being forced upwards. Allowing the shims to be removed and this line of steel shortened.
We took 9 today, but this the third time. We took 7 last time and 8 the time before, so we've basically gone 24 mil.
All that remains is to release the pressure and close the joints. By the time the building has settled into its new position, the top of the skyscraper has shifted to the south by almost 1 inch, bringing it into line with the floors below. All the while, the cladding teams have raced against each other and their deadline. Their goal is to finish adding 12 acres of glass by August. For the past month, Phil's team on the North Core has battled unseasonably high winds. In that time, he's gone back to the drawing board and customized his new cladding system, Cerberus, to make it more resilient.
And what we realised, because of the high winds that we've received recently, that we've now put something in place that can hopefully deal with that with this tension wire system.
No one's ever tried anything like this before, so there's a degree of trial and error involved before they get it right.
As the units come out in the launch area, they'll actually get attached to those cables. They run on runners then, and then it can only move just a little bit in the wind. But that way we've reduced it from swaying and the actual manual labour of trying to hold the unit away from the building. By the time they've come back round, we've already gone up with the next unit. You never know, maybe with this tension wire system we can try and gain something back, but there is a hell of a lot of work to get to that period, that point in time.
Phil's team now needs to work flat out to recover lost time. Keeping the pressure on, he's got younger brother Andy hot on his heels.
I'm sure he'll keep chasing me right to the very end of the project.
We're catching him up. We'll get there, I'm sure. I'll bip him to the post at the top.
2 weeks later, with the North and South cladding teams neck and neck at level 39, the final steel beam at the highest point of the building is about to be fitted.
Yeah, we're going to start lifting the mega beam now, yeah? So we need to get the erectors up as quick as possible, yeah?
Night shift manager Ormond Maxwell does the final checks.
They're ready to lift now, yeah? The column's dressed, the beam's dressed. I'd say this operation should be complete within 3 hours.
It's known as topping out and is the culmination of 17 months non-stop work. The last beam of their 11,000-piece steel frame is too long.
The beam we've planned to put in tonight don't fit. So we've got an engineer up top having a look at it to see why it doesn't fit, and hopefully they can rectify the problem. We'll get this in tonight by hook or by crook, yeah, there's no doubt about that. The boys will work through until that is fitted tonight.
In the end, their only option is to pry open the gap and wedge in the last beam. This may be one of the world's most technologically advanced construction projects, but sometimes it just comes down to a little brute force. The topping out may not have gone quite as planned, but within hours, the crew is celebrating the official completion of the steel megaframe. It marks the start of a new phase in the building's construction.
My role has changed considerably. I've gone from being the project engineer in charge of the daily delivery of the structure to the planning and logistics manager, if you will, on the ground floor. So I've literally moved right from the top of the building to the bottom.
Project engineer Carl has moved down to ground level to begin work on the Galleria, a show-stopping public space 5 stories high.
For the steel frame has meant that we don't have that central core, and so we've managed to free up this huge great space on the ground floor and really open up the whole building. The job is coming to an end. You can see the finishing line.
That final piece of steelwork going in sort of marked the handover between myself and Carl. So Carl's brought all the structure up from ground level, and it signals now the next stage of the build.
On any other project, topping out is a milestone marking the end of major works. But the Leadenhall Building is not like other skyscrapers, and the most important part of their build is still to come. Fitting out the top 4 floors of the tower. They'll contain all the mechanical and electrical services that make the building live and breathe. Normally, a building would put these systems at the very bottom, in the basement. But at Leadenhall, in the fight to maximize rentable floor space, they're going to cram heating equipment, cooling towers, chilling modules, generators, boilers, and control rooms into this space, right at the top. Everything must be slotted through a small hole left in the roof of the building. It's an ingenious idea, but incredibly tough to execute.
It's going to be lifted up with the crane from the ground floor, and it's going to come in through this opening that you can see just here, lowered down onto level 49, and it's probably going to be one of the most challenging parts of the project.
The issue is that up here, space is tight. The floors are just 1/4 the size of the ground level. Using 3D modeling, engineers tried 20 different configurations before working out how they could pack everything in.
As you can see, it's already tight for space. So once the cladding's installed and this is all enclosed, it's going to feel a lot smaller as well. So it's going to be extremely challenging space-wise to make sure we're getting things in the right sequence and they're moved into position, into their final position straight away. Without that 3D model, I don't think it would have been possible up here.
Since the steelwork took 3 months longer than anticipated, Nick needs the system's installation to go without a hitch. He's got to fit 25 units by November.
The way the build's gone at the moment, the structure has overrun, so there is a reasonable amount of pressure now to try and get the fit out, the plant fit out, finished up at these levels.
But nothing can happen until the cladding's done. On the floors below, all eyes are on the Sedge brothers. 11 months ago, they began a race to cover the Leadenhall Building with 75,000 square feet of glass. Older brother Phil is working on the North Core using the new monorail system Cerberus, while younger brother Andy is sticking with good old-fashioned manpower on the south side. They're approaching the newly built finish line, and it's clear who will be taking first place.
Yeah, Phil's beating me. As you can see now, we've finished, got all the way up to the top on level 48, and it's all done now, so it's really good.
Phil's pioneering new installation system, Cerberus, has boosted his team to the top.
Andy knows that I always win. He's having to live with that, unfortunately. We're finished. It's a good achievement.
Andy still has 7 floors of glasswork to go.
I'm on my last level of glass going in. I've got the internals to go in after that. But in regards to the works, yeah, I'm always going to say mine was probably a bit tougher.
August 2013. It's 23 months since the major building work began at Leadenhall. The steel frame is complete and standing up straight. All the floors have been laid and the cladding is finished. It means that it's time for the critical power systems to be installed on the topmost floors of the 736-foot tall tower. First up, one of 4 18-ton generators. It's a delicate operation. One small knock could damage the $1.4 million mechanism.
I mean, you're taking this in 7 metres away from your cab window, and that's got to be about 12, 14 metres long, isn't it? So that's what worries you when it's windy, if it spins on you. Right, now we're going down through the letterbox from 51 down to 48. The hole we're going down is virtually the size of the machine, so we've got to take this real slow once we get through. You'll see a couple of lads down there are going to help us on the tag line. Once we get through the top here, Brian the bank's going to take over for us.
Jimmy must slide the generator through a narrow slot that's been left in the attic's roof.
Once we go through the top here, that hole narrows. As we go down, it gets narrower. So, I don't know if you can see from there, but you've only got inches coming. When you get down the next floor, literally the inches.
Coming down. We're coming, Jim, down a little here. Keep it coming, Jim, keep it coming. Keep it coming, boy, keep coming down. Okay, keep touching onto the left. Just hitting up as you're going, Jim.
Are you happy with us? You all right, Bassett?
Yeah, happy with everything.
Yeah, come down. Right, come down easy, Jim. Down you come.
The first key piece is in. Now everything else must be positioned around it. By following the detailed 3D model, Jimmy and the team install 4 floors of systems so fast that they are able to claw back the 3 months lost to the steelwork overrun. With all of the main systems installed, they're ready to plug into the power grid, flick the switch, and bring the Leadenhall building to life. Almost 40,000 components have been assembled in under 2 years. A European construction record for a building of this size. The architects, engineers, and construction workers at the Leadenhall building have pushed the limits of what can be achieved in the smallest of spaces and tightest of schedules.
When we've been engrossed in it as much as we have, it's very hard to stand back and see just what we've actually achieved over the last 2 years. And we really have achieved something very, very special in a very short period of time. It's an absolute celebration of engineering.
In the heart of an ancient city, the building of the future has arrived. Right on schedule.